Good morning, good afternoon, or good evening. Thank you for joining the second part of ABB Process Industries webinar series on sustainability. Today, we continue to explore how digital champions manage energy. For the next 30 minutes, our digital specialist, Anis Korchi, Portfolio Manager for Sustainability, together with Nazneen Azari from Solution Consulting, will share case studies about advanced digital tools. It will be followed by a product demo of ABB Energy Management and Optimization software. Towards the end, we will also dedicate about 10 minutes for question and answers. So please feel free to drop in your questions in the chat window. And I would now like to invite Anis Kurchi to take this session forward. I hope you find the session insightful. Thank you.
Thank you, Arti, and thank you everybody for joining this part 2 of our webinar series. As a reminder, during the last session we had 2 weeks ago, we mentioned that energy cost variations and the regulatory pressure are urging the industrial sector to rethink the way it manages energy. Today, I would like to highlight that with those pressure come also several incentives. And you have here on the screen few examples of government programs that can accelerate your decarbonization journey. In general, and more often, one key criteria to benefit from those programs is to have an energy management system in your organization. There are several standards out there, but one which is widely followed in our industry is the ISO 50001 certification. We see it growing in number across the globe and across our verticals. And more and more the organizations are following that. They are implementing it in order to benefit from the beneficial cycle we explained in the previous webinar, which is monitoring our energy, do some forecasting, and then step up with optimization exercises. Those organizations are also following this certification to show their engagement towards decarbonization, and they would like to show it to their supply chain partners and also to the local authorities. We would like to illustrate this with a case study from one of our clients in China. This client was recognized by the international organization Clean Energy Ministerial. The case study you have here, again, that's a cement plant in China which has followed the certification of energy management. And they have also well documented the progress over a 5-year period. The leadership of this company pushed hard, pushed positively for their team to set what we call the science-based targets. That's one. They also pushed to have a continuous evaluation process and to introduce all of that into their daily processes in order to have the right accountabilities and responsibilities within their company. Several initiatives were run to lower their coal consumption. Examples are that they use alternative fuels, but other examples are related to introducing energy-efficient equipment. Doing so, they were able to reduce their energy consumption by almost 8%. And of course, there are several factors that can explain that. Software, yes, it's one of them, but it is not the main parameter in there. But we still need to explain that without a proper energy management software, a well-structured analysis of their energy consumption, a data-driven program also would not have been possible. By going with that approach, this client was evaluated by an external auditor as an enterprise which is outperforming its peers, not only in China, but also abroad. Here you have another example in the mining industry where embedding sustainability into the daily operation was done successfully. Within their centralized control system, this client has run an energy management software along other technologies like substation automation, power control, advanced process control, and also an extensive predictive maintenance. All of those building blocks or digital Legos enable the client to install new processes to reduce their water usage by almost 90%. They also reduce their fuel consumption by around 70 to 80%, and they also divide their greenhouse gases by two. So it's quite an achievement, but this achievement can be pushed much further by introducing solutions to do energy forecasting and optimization. And this is what we will try to demonstrate in the coming slides. Here, I would like to explain that energy optimization can be done in different ways. And one of the options is to do load management. It is about using an asset when demand is small. To better explain this concept, I will use a simple case from our everyday life, which is commuting to work. So let's imagine this is me commuting to work using an asset which we call the road, the national road. Living downtown means driving to work against the traffic flow and avoiding most of the traffic jams. This means I'm using that asset, the road, when its utilization rate is low. The same thing happens in the evening driving back home. So the conclusion here is that my load balancing for the asset, which is the road, is fairly good, but there is still room to improve this. In fact, I will find the total optimum by shifting my demand pattern even further in the night when there is even less traffic and close to unlimited supply of this asset, which is the road capacity. In fact, some of the traffic lights are blinking during the night, so it makes my commuting quite smooth. I don't need to accelerate, stop, and start again my vehicle, so more efficient in terms of energy consumption. So now by doing that, I have an optimized solution against one asset. Again, that's the road. My travel time is at the minimum and cannot be improved further. If there would be a road market, the price for that asset would be optimal at those times. But reality is a bit more complex because we cannot just drive in by night. We have other commitments. We need to spend time with the family. We need to sleep to be productive during the daytime. So here we need to rethink a bit this optimization and adapt it to those daily constraints that we have. Taking into account those constraints, we can then build a cost function leading to the optimal schedule of my commuting. In practice and also intuitively, it will mean that we will leave home a bit earlier at dawn and drive back at home before the rush hour. So quite intuitive. We don't need complex formulas to get to that conclusion. And we don't neither need a complex spreadsheet to do that. But if we go back to the industrial setup, I would have hundreds of those constraints, if not thousands. The situation would also change constantly every 15 minutes, depending on the energy market. And also, we may have several assets to optimize in parallel. So this intuitive analysis and also simple spreadsheet and with few linear equations will quickly fall me short when trying to optimize the situation. So this is why we would like to introduce you a different way of doing it, a bit more sophisticated, using a digital solution. To illustrate that, this is a client we have in the metal industry. This client has a complex melt shop that includes several constraints related to the melting configurations, but also different constraints related to the processing, transportation, setup, and cleanup activities. The customer objective here was to reduce its energy cost and be able to run various simulations and what-if analysis. One of the key assets they wanted to optimize was the electric arc furnace, which is a high consumer. We have thus enabled a digital energy optimization system that automatically generates an optimal production schedule for the next 7 days. It takes into account the energy prices in the volatile electricity market, but it also takes into account maintenance plans, the current status of the melt shop, the availability of different equipment, but also penalties and violations of hold-up times between stages of the process. Overall, we were able to provide 2 to 5% energy cost reductions, which is quite sizable when you look at the absolute energy consumption of this client. I will use this slide just to summarize a bit the fact that there are several ways to do energy optimization. The one that we have discussed in the previous slides is what we call it is what is more focused on the demand side. So we are scheduling our assets, taking into account production flexibilities and the production buffers. There is another way to optimize. It is about looking at the energy supply, especially when our assets, when our sites have access to the electricity from the grid, but also you may have your own powerhouse, maybe some additional renewable energies, and also some energy storage facilities that are directly in your site. And the key question is, how do you balance all of that in order to reduce your overall energy costs? So I will give now the lead to Nazanin, my colleague, to take you through a few examples that will explain that. Thank you all.
Thank you, Anis. Handling the supply side of the energy is also an interesting topic. And now, just like this pulp and paper customer with 14 mills across Europe, I want to give you this example. The company has its own generation and shares in various power plants, and it faces the complexity arising from variable, but also potential that they have with the more affordable electricity prices on an hourly basis in a day-ahead market, and also by planning to switch to 15 minutes time steps. The optimization in this case is around energy source balancing and energy trading opportunities. Energy cost optimization takes into account all available resources, their prices, and the operational constraints they have. Additional profits were realized from effective use of energy reserves and hydropower here. This customer reported that the initial system payback was only a few months. What else could be optimized? Let's go to another case study from the pulp and paper. So pulp and paper mills have boilers, which represent another complex optimization problem. And not only it is the steam needed at different but very specific pressure and temperature, but it also the consumption rate is highly variable due to variability of the process conditions, trip starts of the steam consumer, and so on. Steam network stability and reliable power output are difficult to attain. And on the top of this, further constraints are added by variable prices and local rules for energy market. And this is a perfect case for an advanced process control solution, which was successfully implemented in digester, bleach pulverized fuel boiler plants. It brought 3 to 5% savings in the steam cost and pays itself in less than a year. This South African mill ensures a much more stable and reliable energy supply thanks to digitalization. One more digital champion that I would like to talk about today is an integrated steel mill. Energy represents about 20% of their production costs, and therefore energy efficiency is crucial for both profitability as well as their environmental policy. An integrated steel mill generates higher calorific value byproduct gases at varying rates. The differences between gas generation and consumption rates are compensated with gas holders. However, under certain circumstances, the imbalances can lead to the flaring of excessive gas or require the purchase of the supplementary fuel. ABB's energy management system has sophisticated monitoring, planning, and optimization tools to model complex energy interconnections between various processes of the mill. It determines the optimal trade-off between gas holder, lever control, flare minimization, and optimization of the electricity purchase versus the internal power generation. The system not only reduces the cost, it improves energy efficiency, but also manages carbon footprint and provides environmental reporting features. To summarize today's session, the typical steps and the modular approach for deploying digital solutions for industrial energy management is the first step to monitor energy usage at plant and process level with a real-time visualization and displaying the data. With that, you can identify best performance of the process areas and opportunities for improvement, and get the report of the energy consumption patterns of the process areas and production line helps you to analyze inefficiencies in the plant and the process areas. By setting up the alarms and notification that corrective measures can be taken immediately, and for forecasting energy consumption schedules for process area based on the production plans and measure consumption, as well as solve real-time economic optimization problems, which consists your own generation, trading, and using energy industrial plants and power plants helps you to save costs on your side. As you could see today during the case studies, there are no two plants that use the energy in the same way. Energy price fluctuations, time vary, transfer, conversion and of utilities, as well as renewables, may disturb highly sensitive continuous processes. This may increase also the energy cost and has negative impact on product quality or even result in downtime. That's why the industrial plants need a purpose-built energy management system that adapts to their specific processes, energy mix, and local market and regulation. Let's quickly show you how it works. In my demo, we have specific demos for mining and for metals, as well as for pulp and paper. And based on today's attendee statistic, I would like to show you the pulp and paper demo. Keep in mind that this demo consists dummy data and simulations, so that's one thing to mention. So most of the mills have ambitious sustainability targets, and they may still use Excel to aggregate data and the total energy consumption and cost. And there are also some calculations and data tracking being done in a semi-manual way. And to generate an ESG report, it will be time consuming, and sometimes it takes up to 5 days to consolidate that data. But having a kind of a modern digital platform for energy and sustainability enterprise on an enterprise or your plant level can automate this kind of report generation. By having the dashboard view, as you see, you can have an overview of your whole system and plant in one glance. And it visualizes the trends for the energy consumption. And we are not just talking about electricity, we are talking about the steam, the gases, water, and also specific energy. And we also mentioned the environmental KPIs like the wastewater and CO2 or green energy rates. And having those and also being able to adapt that to the roles that you need on the site, which need to track this kind of values and also track them on a different kind of resolution, would help you to be more efficient on this area and be able to reduce at least 40% of the time you require for doing this reporting and analytics. And this also will help you to maintain and obtain the ISO 50001 certification. Since you have this platform, it is also easy for you as you are introducing renewables to your plant or new processes in your system, as well as if you are starting to participating in the energy market. By having automatic notification, you can also see the abnormalities and uncommon patterns in your system, be able to investigate on that, and as well as be able to track and do actions. Let's go to our consumption. So over here, you have the real-time online tool, and you don't need to wait for a report from each department. And you can also see the comments as well as disturbances that are happening on the site to basically define the deviations that is happening and why you're far from your target or your forecast. And by having a granularity of the data coming from each part of your plant and also what you are getting from each department, you can basically track and make the better analytics and also decision making on your site. Going forward, to avoid the energy demand and the supply risk and lower your costs, you need to understand which type of energy is consumed the most and when. And our system lets you analyze to do the consumption distribution via energy type on your plant, as you see here. So we have different types of energy present on the site. And the forecast will also show you when more electricity from the grid will be required. And also, if you have an accurate forecast, your procurement department will be able to notify and be able to adjust accordingly. And beside that, of course, you have the reporting tool to basically report on the variables and the data you need, and also be able to subscribe to that if that needs to be done on a regular basis. Another analytic tool that I want to mention is the contracted energy consumption. It's a tie line diagram, which gives you the opportunity to get the information that you have from your production planning and the mill, and be able to see also your energy consumption calculated. For example, here you can activate an alarm, which gives you the heads up. So if you are deviating and you're leading to the penalties, and you can then make the decision if you take the penalty charges or you allocate the costs respectively, or you change the plans inside of your site. As well as having the overview of your energy flow with the Sankey diagram, it will help you to trace where the energy is going and how it's being used inside of your plant. Another way of analytics is the energy efficiency analytics. Our system enables a demand-side energy management, exploiting the real-time energy. And here you can see how the regression is being made within your product volume and also the specific energy, and gives you the tools and power to analyze your production plan and making decisions. You can have the same overview for your energy, for your emission. So you can see the emission flow, or basically the emission trends on your site. And if you are making any kind of programs to reduce your emissions, you can have the way to compare that from last year and be able also to forecast how you're going based on your production. Moving forward, we have also the optimization case, in this case for the pulp and paper. So our system helps you to understand the demand side energy and also the real-time price of the coming from the market, as well as the process flexibilities. And it should help you to do the optimization on your plants. If you want to know more about these kind of optimizations, please get in touch with us. Also, moving forward, one of the essentials to move toward the sustainability is to define goals, and having goals and projects and be able to trace and track on that, as well as defining the KPIs and tracing the KPIs is available on the system, and it helps you to come up and basically be able to get in touch and have like an understandable and good data and analytics toward your projects, and what is happening on your plant. That can be also mentioned for the alert, so you can do that kind of overview on the alert, make the notifications, and as well as apply projects. So I would like to change to the presentation. Thank you. Before we move to Q&A session, I would like to invite you to the third part of our webinar series. We will cover more digital solutions such as industrial water treatment optimization, predictive emission monitoring, and connected workforce apps. There are also lessons learned from integrating sustainability into centralized operations in combination with our digital solutions and leveraging industrial analytics, artificial intelligence, and machine learning. There are many more champions from the cement, mining, metals, pulp and paper, and other industries who think big and get practical. Please join us on 18th of May. There will be also 2 options to accommodate different time zones for you. So by saying that, how can we help your company to be more energy aware and discover new opportunities around the sustainability? Would you like ABB to access your energy performance and improvement potential? I simply type yes in the chat right now. We will get back to you by email, which is provided to us by the registration. You can also scan the QR code shown in the screen and contact us via this website. Thank you very much for listening. I think we can start the Q&A session.
Thank you, Anis. Thank you, Nazni. I hope you liked the demo and found the case studies useful. Let's kickstart the Q&A session. I see some questions posted on the chat window. Anis, this first question is for you. Who are the typical users of an AMS system?
Thank you, Arti. I think we need to answer that question by looking use case by use case. If we start with the monitoring feature of the EMS, I would say that the typical user will be the environmental manager, but also the maintenance team and the energy efficiency team. Those people are going to use the platform as a decision support tool on one side, but they will also use it as a platform to be able to be reactive in case of any immediate inefficiency that happens during the operations. In addition, still for the use case of monitoring, the executive team could be looking at that, not to go into the details of each equipment energy consumption, but more to have a larger view of their energy footprint and environmental footprint at a plant level and across plants. Then when we move to the other use cases like forecasting and optimization, we will have the production planners that will try to ask the question, how do I schedule my operations in an efficient way in terms of energy costs? But we will also have users as the energy procurement teams or the trading teams who are asking themselves how much energy they need to secure in the next few days or weeks. But we can also have the power plant manager who is handling your own powerhouse in order to make sure that the right equipments are available at the right time. So this is the kind of users we see for the energy manager software.
Thank you, Anis. There's another question for you. Which KPIs do you recommend to track?
Okay, sure. So I will start by mentioning a typical term we use in the literature of energy efficiency, which is the wages. Wages stands for water, air, gas, electricity, and steam. So those are, I would say, the typical energy types to look after. you can look at those energy types either at an equipment level or you can vary the granularity level, process area at the plant or across the plants. It is really important also not to look at those metrics in an absolute manner, but also to look at it in terms of intensity or what we call specific energies, which is an energy divided by a unit of production. This will help you then to compare your efficiency across different time periods. One other element which is important to track now, it's the emissions that are related to those energy sources. And with our software, you can do it in different ways. So you would either use emission factors to translate some of your energies to an equivalent CO2. However, we can also then connect with other instrumentations in your plant to get the data directly, either with the analyzers or maybe with other digital solutions. For example, the PEMS, the predictive emission monitoring system that we will feature in the next webinar in 2 weeks' time. Thanks, Arki.
Thanks, Anis. Nazneen, I have a couple of questions for you here. So, energy-related data is highly sensitive data for a company. What measures do you take to protect it?
The first thing I have to mention is that we follow ABB's strict cybersecurity guidelines. You can check it out in our website. I can also share the data if you need to. In addition to that, we always engage with the customers. So if they want to keep most of the data on their premises, then we also commit to that. We take the minimum to the cloud. We follow basically what the customer wants, and we are fully flexible and scalable in that standpoint. And we try to keep the data as safe as possible. Thank you.
Thanks. What data protocol do you use? How open is the system, Nazneen?
So we are capable of integrating other vendors and standard protocols which follow OPC and Modbus. And we also perform specific integration of the during the projects if it's needed, and also to the grid if it's needed. And on the other hand, our platform is capable of providing information via secure OPC, as well as a REST API. So I would say we are very open to that. Thank you.
Anis, I have a question for you. We already have energy monitoring. Can we just add this forecasting or optimization?
Yes, it would make sense to go after that, and we can do that because those value propositions we have are modularized in the sense you can pick and choose. In the ideal setup, we are suggesting the monitoring package and then step up to the forecasting and optimization, but there is no issue to start directly in step 2. And of course, we will have to discuss on a case-by-case basis to see how we can integrate that in the most efficient way while leveraging your existing system.
Anis, is this a one-time purchase or subscription-based?
We are positioning this offering as a subscription with a subscription model, and this is something that we see more and more in our markets. I'm happy to reach out to the person who asked this question to go into more details.
Thank you. I have one last question in the chat window. Nazneen, if you could take this. Does the system consolidate data on an enterprise level?
Yes. We can start from minimal viable products, like a very small, and then scale it up to the enterprise level.
Okay.
And I think we've mentioned that in the previous webinar, but a typical example of that is a mining company we worked with where we have delivered the solution again at the enterprise level, and it gave the ability to the headquarters to monitor several mines and several harbors across the geographies they are operating in.
Okay. Thank you, Anis. Thanks, Nazneen. We are done with the questions here. But if you have more questions, please don't hesitate to contact us. And we would be sharing the recording of the session along with the presentation deck with everyone who's registered. Thank you very much for joining us today, and we look forward to having you on May 18th. That's the third part of this webinar series. Thank you very much.
Thank you.
You.